All right, welcome to lesson 19 and 20. Today we're going to be talking about how to solve one variable inequalities. So last lesson we introduced to you what an inequality is, how can we represent inequalities in different situations, and so today we're going to talk about different solutions to inequalities in one variable. So our learning goal for today is let's find and interpret solutions to inequalities in one variable. Our warm-up, write some solutions to inequality y is less than or equal to 9 plus point 2. Be prepared to explain what makes a value solution to this inequality. Remember, a solution to an inequality is the value of the variable. So what can you substitute in for y that is going to make that a true statement? So what numbers are less than or equal to 9.2? For the second part, write one solution to the inequality 7 multiplied by 3 minus x is greater than 14. Try a bunch of numbers. See, give me at least one solution that is true for that inequality. In this lesson, we're going to be using a lot of number lines as well. The number line is introduced to you at the top here. It is just, if you were thinking of it being a graph, it's just right, your x-axis, your horizontal axis. We're starting from negatives on the left and the positives on the right. So you could always draw a number line for you as you are going through each of the lessons here. So let's get into it. We are my bad. A teacher is choosing between two options for a class field trip to an orchard. Orchard A, the admission costs $9 per person. 3 chaperones are required. At Orchard B, the cost is $10 per person, but only 1 chaperone is required. At each orchard, the same price applies both to chaperones and to students. So, which orchard would be cheaper if the class has 8 students, 12 students, or 30 students? I want you to take a moment now and substitute, right? If it's $9 per person, we have 8 students plus another 3 chaperones. So 8, 9, 10, 11. So 11 people, $9 per person. How much is it going to cost you total? Orchard B, we have 8 students plus 1 chaperone. So that's 9 students multiplied by $10 per person. How much is that going to cost? And so I want you to do that for each one and tell me which is the cheaper option for whether I take 8 students, 12 students, or 30 students. To help her compare the cost of her two options, the teacher first writes the equation 9 multiplied by n plus 3 is equal to 10n plus 1. And then she writes the inequality 9n plus 3 is less than 10n plus 1. You want to answer the couple questions here. What does n represent in this statement? What is my unknown here? What don't I know? And I'll give you a hint to look back to number 1. What is it? What is something that's varying, right? What's my variable here? What's varying in this situation? In this situation, what does the equation 9n plus 3 equals 10n plus 1 mean? And what does the solution to the inequality 9n plus 3 is less than 10n plus 1 tell us? And I want you to graph that solution to the inequality on the number line. So in the situation, what does the equation mean? It means when, right, the cost of orchard A and orchard B are what sign do you see for B, right? What does that sign represent? So it's when those two costs are what? And so, what does the solutions to inequality 9n plus 3 is less than 10n plus 1 tell us, right? It tells us what does n represent here? What thinking back to what you answered for A, it represents what on the field trip and which one would be cheaper, right? At which it would be cheaper to visit Orchard A or Orchard B. And so you want to tell me what N is. So what is N here on the field trip at which it would be blank, cheaper, more expensive? It depends on how you phrase it, how you read that inequality, whether you read it from left to right or right to left. Cheaper or more expensive to visit Orchard A or Orchard B. Okay, try to give me a full sentence on what that solution to the inequality represents. For your next statement, I want you to graph the solution to the inequality on the number line. I'm going to show you 3 different ways you can solve inequalities. You can use any 3 ways you would like. I'm going to introduce one way to you right now. I'm going to introduce to you 2 other ways in a couple of minutes, and I'll give you examples for all of them. So, one way is to just solve the inequality as an inequality. So, my first step here to solve for my variable n is to distribute your 9 and 10 to both your terms, right? 9 times n is 9n, 9 times 3 is 27. 10 times n is 10n, 10 times 1 is 10. After that, to get n by itself, I'm going to subtract 10 on both sides. That gives me 9n plus 17 is less than 10n. To get all my n, to isolate my n, I want all my n's on one side, so I'm going to subtract by 9n on both sides, which is going to give me 17 is less than n, or n is greater than 17. And so if I have my number line, I'm going to create an open circle and draw a line in that direction. I'll explain what that looks like in a second. So how did I know to draw my inequality? So in this case, n is greater than 17. I am not including 17 in that value, right? I'm talking about anything that's greater than 17. I always like to use example of your age, right? If you are, let's say you have a sibling who is 10. That sibling is greater than 9 years old, right? He's not 9, he's greater than 9 years old. We're not including 9 because he's older than 9, but he's greater than 9 years old. And so a closed circle would mean if I'm including the value, so something that is greater than or equal to, or less than or equal to. And so when I'm talking about strictly, that means I'm including that value. So your brother is greater than or equal to 10 years old. And so we're including that value, and so we use a filled in or a closed circle. So in this case, we're using an open circle because it's n is greater than 17. And so I'm going to draw a open circle and then draw an arrow going that way. And so this is a nice key for you to have if you want to create a little table for yourself in your guided notes as well. So Andre and Priya used two different strategies for solving the inequality but reached the same solution. There are two more strategies given to you as well. I want you to read through both of these strategies and make sense for it to yourself and figure out what is going on here. But what both of them do, and what you're going to notice here, do you look at the beginning and you'll see that both of them are solving this inequality as an equation first. And this is very useful because you're familiar with solving equations. We've been doing it over the past couple of months since you've been here. And many of you started doing that in 8th grade. So if you solve something as an equation first, that is something you are comfortable with. And then what you're going to do is you test a point to see where your solution set is. And so if you look at Andres, he tests if x equals -4 is a solution. Priya, instead of testing a point exactly, she reasons through. She uses logic and understanding to realize, okay, x must be less than 3. And you can read, I want you to take a moment and read through both of those, write little notes to yourself trying to figure out which strategy you like better, what is more helpful for you as you are solving your equations. I'm going to go through an example using Andre because I think it's very helpful for you to see what that looks like. So for the next part, matching inequalities and solutions, I want you to match each inequality to a graph that represents its solution. I want you to explain and show your reasoning. I gave you that last page on there to do it. I'm going to go over number 5 with you using Andre's method. So using Andre's method, we're going to start off with our inequality here. I'm going to solve it as an equation first. So to solve it as an equation first, this is just strictly solving for x. I want to get x by itself. The first thing I need to do is notice that we're dividing by 3. The opposite of dividing by 3 is going to be multiplying by 3 on both sides. So if I multiply by 3 on both sides, it's going to give me 4x minus 1 is equal to -3. To get x by itself, what else do I need to get rid of? I need to get rid of that 4 and the -1. The first thing I'm going to do is I see that subtraction. What's the opposite of subtraction is addition. So I'm going to add 1 on both sides. That's going to give me 4x is equal to -2. 4 and x are being multiplied together, so the opposite operation of multiplication is division. And so I'm going to divide by 4 on both sides, and that's going to give me x is equal to -1, 2 over 4, or x is equal to -1 over 2. We're not done yet though, right? We solved it as an equation. And so step 2 is how do we solve it as an inequality now? And so we are going to test a point to see where the solution set is. You want to test something that's not -1/2. And so we'll choose any number. It doesn't matter which way you choose. So I'm going to choose a nice easy one. I'm going to test x is equal to 0. So when x is equal to 0, I have 4 times 0 minus 1 divided by 3 is greater than negative 1. That tells me 0 minus 1 is divided by negative 3 is greater than negative 1. And negative 1 divided by 3 is greater than negative 1. That is a true statement, right? Negative 1 over 3 is greater than negative 1. Negative 1 is more negative. And this is where I told you, if you need to draw a number line to see that, make sure you have that number line drawn out to see that. Since the inequality is true, so 0 is a solution. So if a number greater than negative 1/2 is a solution, the solution must be all numbers greater than negative 1/2, right? If that inequality is part of our solution set, then all numbers greater than negative 1/2 are part of that solution set. And so my solution set is any number greater than negative 1/2. If 0 was not a solution, then all numbers less than negative 1/2 would have been your solution. And so here you're just testing, is it true or is it not true? If it is true, then it's part of your solution. Then you choose whichever greater than or less than sign actually fits that solution. If it's not true, then you draw a little X and you point your arrow the other way. And so since we know that X is greater than negative 1/2, your final step, determine if it's going to be an open or closed circle. In this case, we have an open circle since it's strictly greater than negative 1/2. And so we have an open circle. And so we know that it is not letter A, right? We see here that 0 is a solution to my inequality. 0 is a solution to my inequality. Because it's a solution to my inequality, anything greater than than negative 1/2 is a solution to my inequality. If it wasn't, right, if 0 was not a solution, right, if it gave me a false statement, you would draw your inequality the other way. You would take this and go all the way down that way, right? That would be your solution. And so if you need to draw that check mark or that X mark while you're doing it, that's going to be very helpful for you, where you cannot cross anything that is a check or an X. So you draw that open or closed circle. You start off with your open or closed circle. Then since 0 is a solution, I'm going to draw everything to the right of negative 1/2. And that is my solution set. And so I want you to show your work for every single other inequality in there and match it to the correct inequality. And so all of our learning targets here, right? You can graph the solution to an inequality one variable. You can solve it and interpret the solution in the situation. And you understand that the solution to the inequality is a range of values. Remember, with inequalities, we have more than one solution. Think about y is less than 9.2, which we saw in the very beginning. There are so many numbers that are solutions to that inequality. So we have more than one solution to our inequality when we are dealing with inequalities instead of equations where we have equalities. So we'll talk about this more in the next couple of lessons, but I look forward to seeing you there.